is a method here that you can also use both your eyes and your ears. Okay, there are two types of ultrasonic inspection. Okay, we have the pulse echo method and the resonance method. Okay, so this here, okay, so this is the how powerful you see. So from 0.5 megahertz to 25 megahertz. So imagine that. So from 5,000 cycles per second, okay, to 25 millions per second. So that can be detect. So there are two methods. Okay, the pulse echo method and the resonance echo method. Okay. For the pulse echo method on the left side of the screen, if you look at it, it mainly uses pulse. Now, for example, okay, if you see that there's the transducer, okay, and they have the plate metal behind it. If you pass it through, like when it detects a crack inside, it will actually give a small wave on the screen. So if you look at a small triangle, small pulse, that means, there is a crack. Why? Okay, maybe I should go there. Now, because why does it have to be small here? Because if you look at here, when it reaches the crack here, the distance is very small. So that's why the distance is also very short. Now, when this transducer passes here without any crack, if you see here, okay, so the distance in the plate is longer. That's why it also gives you a bigger wave. Okay. Now, there is the resonance method. It's very simple. So it uses the transducer, a different type of transducer. It's connected to your computer. Okay, so when you pass it through the transducer, it will also give the same frequency. If it passes through a crack inside, it also gives you a small wave, and it passes through a bigger, without any cracks, also gives you a big wave. So it has the same principle actually. The difference is that this is what is used as a pulse echo. You do one more resonance, so resonance, so meaning to say it resonates. Okay, so this is the difference between the two methods. The first one is the pulse energy introduced into the structure. So pulsuhan siya. Okay, then the energy travels through the material to the opposite side, and then it bounces back. Okay, so there's an echo. So the pulse is received by transducer. So it's like when you are on top of a mountain and you shout, and then you hear your voice going back to you. Because once your voice hits a certain mountain or a certain block, the sound goes back to you. So that's how it is. Okay, echo. Then it displays on a cathode ray oscilloscope, okay, the monitor, as a spike which establishes the time base, representing the thickness of the material. So if you recall, let me go back. Sorry. Okay, if you look at that high, on the left side, the leftmost side, the very high, this one. Okay, this will tell you how thick your surface is. Okay, it changes